Today our lesson is about what's called scatter plots. Scatter plots are graphs that show if there's a relationship between two sets of data. Scientists use these, mathematicians use these, and business owners use these. So just as an example, let's say I run a snow cone shop, and I want to know if the temperature outside is related to my sales. What do y'all think? What do y'all think? As it gets hotter, what's probably going to happen with snow cone sales? They're going to go up. So if I was a business owner that did snow cone sales, I would document my data and I would say, here's the high temperature Monday, and then I would put how many sales I had. Here's the high temperature Tuesday, and maybe do it over the whole year. And then I would graph it so that I could see if there's a relationship between temperature and snow cone sales. Okay? And then what you're going to do is you're going to see if there is a relationship, what kind of relationship is there. So does this graph show a relationship? Like, do y'all see a trend happening? Yes or no? If they're moving together, the dots, there's a trend happening. If they're moving upward, it's called a positive linear trend. This is a positive linear trend. Now, obviously, it's not a straight line if I was to connect the dots, right? But it's moving in a straight line direction. Yes? So this would be like if I was to graph the temperature outside in snow cone cells. As the temperature increases, what's happening to the snow cone cells? They're also increasing. This next graph, what do y'all think? Is there a trend being shown? No. This would be like if I took y'all's grades on your last test and your height. There's going to be dots all over the place because short people score well, tall people score well, right? It has nothing to do with one another. So this is called no correlation. You also might see it written as no association. So no association. It will be either way. This last one, do y'all think a trend is happening? What do you think it is? What else? Linear. It's a negative linear relationship. So an example of this would be like the temperature outside and snow ski rentals. What's going to happen as it warms up on the mountain? They're going to decrease because the snow starts melting and people aren't skiing as much, right? Okay, so this is what scatter plots are all about. The next thing we're going to learn is how to make a scatter plot, and this is the easiest thing ever. You just graph the coordinates, okay? So right here it says make a scatter plot of the data in the table. So we're going to graph the type of fish, the length of their bodies, and how fast they swim. So I would go to the x-axis. What is it labeled? Length. So what should be over here? Speed. And you're basically just going to graph each coordinate. So when a fish is 37.8, so I find here's 30, here's 35, 37.8 somewhere in here. You just kind of make your best guess. It swims about 148 centimeters per second. So like somewhere up here. All right, so y'all are going to go graph all of those points right now. I'm going to graph in red so I can see them better. Did that one. Okay, did y'all get a graph? Now we're going to answer a question. Describe the correlation. Are y'all seeing a relationship between the length of a fish and how fast they swim? Yes, I am. What kind of relationship are y'all seeing? A positive correlation. So I would write, this is a positive correlation, and then I would explain, as length increases, what's happening to speed? Speed tends to increase. Okay, let's go look at this example. It says the table shows the number of active red woodpecker clusters in a national forest. Make a scatter plot from the table above. Now, real quick, look at the x-axis. What does it say? Years since 2005. And then this graph, I think that we put the wrong graph on there. So just mark those out, and we need to put years since 2005. So here's 2005. Can we count by one since it's going up by ones? So this first one's going to be 1, 2, 3, 4, and so forth. So those are the years since 2005. All right, so we're going to go graph this. 2005 would be at 22, so we're going to be at 022 because it's years since 2005. So if you want, you can go put up here, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, because that's how many years from 2005. And then I want you to go graph those on this graph. All right, it says, describe the correlation of the data. What do y'all think? It's a positive correlation, and give me more. As the years increase, the clusters increase. So as years increase, comma, the clusters increase. Okay, now, right here it says write an equation of the line of best fit. This is called a trend line. Okay, a line of best fit is called a trend line. What a trend line is a line that goes through a scatter plot that best represents the trend. Now, y'all don't have to go back to the front. I just want to kind of show you. So if I had, let me get a straight edge. Here we go. If I drew a line of best fit through these dots, it would basically go through the middle of the dots, following the pattern of the trend. Do y'all see that? Like, that's probably not perfect, but I did my best. And like this one would be like this. Maybe a little more down. Are y'all with me? So when they ask you to write an equation of a line of best fit, they're asking for the equation of the trend line. Now, if I just free-handed a trend line, are all of our answers going to be different? Yes. And so what we're going to do is I'm going to teach you how to use your calculator. Your calculator will give you a line of best fit by using STAT. You already know how to use STAT. The thing is because this is not a straight line, y'all agree, right? But is the trend moving in a straight line? Yes. You will have to put in every single piece of data. You can't just use two. Okay? So what you're going to do is you're going to go to STAT over here. So write your steps. You're going to go to STAT Edit. You're going to put L1 for your X's, L2 for your Y's, but you have to use every single coordinate that's given to you. Okay? And then you're going to do exactly what we've already been doing. You're going to go to STAT. You're going to tab over to Calc. You're going to choose option 4, and you're going to hit enter until it gives you an equation in y equals mx plus b form. That equation that STAT is giving you is the equation of the line that would best fit this data. It's not a line that connects the dots. It's a line of best fit. Does that make sense? Okay, so let's go put this data in. So go to STAT Edit, clear everything out. For your L1s, you're going to put in your 0 through 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And your L2s, you're going to put in your active clusters. Okay, so now we're going to go to Stat Calc, option 4. What is the equation of the line of best fit? Y equals, anybody? 3.7x plus, and usually it will tell you like what to round to, but don't round to the whole number. I would round, let's just round to the 10th place. So 19.9. And that is the equation of the line of best fit. Okay, so they're saying that if I drew a line of best fit through here, it would pass through the y-axis at almost 20. Isn't that really close to that dot? Now, it doesn't say that it's going to connect the dots or pass through the dots. It's going to pass through at best fit. Can you now use this equation to make a prediction? Yes, so we're going to ask a question. I should have typed it for y'all, but I didn't, but write this down. How many woodpecker clusters would there be today? How many woodpecker clusters would there be today? So how would we use this equation to solve? Well, the clusters are on the y-axis, yes, and the years since 2005 are on the x-axis. Well, what year are we in today? 2024. How many years since 2005 is that? 19 years. So we're going to plug 19 in for which value, x or y? For x. So in 2024, we are 19 years from 2005. So I'm going to plug in my equation. My equation is y equals 3.7x plus 19.9. Where did I get that from? The line of best fit. I got it from STAT, yes? So I'm going to take 19 years and I'm going to plug it in for x. So I would do y equals 3.7 times 19 plus 19.9. So 3.7 times 19 plus 19.9. Oh, I totally messed that up. 19.9. How many woodpecker clusters would there be today approximately? 90.2 clusters. And that is a guess, that is an estimate, that if the trend was to continue in the same pattern it has been, there would be about 90.2 clusters today. Does that make sense? Okay, skip the bottom, we're going to come back to it. Go to this page. I want to talk to y'all about the correlation coefficient. And every year on the STAR EOC, there's one question asked about this, and a lot of times my students have forgotten about it. Okay, so do y'all see how in STAT, when I calculated my entry, it gave me an equation? Now, is this a weak correlation or a strong correlation? Do y'all know what that means? Like, look at the line. How tightly together are the dots? Pretty close, right? Where like over here, they're kind of way more spread out. See how the dots are kind of more spread out? There's still a trend, but they're more spread out. So this is a little bit weaker than this one. Look how close those dots are together. Does that make sense? All right, so I want to talk to you about correlation coefficient. In your calculator, there is a way to see if the trend is strong or weak. It is called the correlation coefficient. It is denoted by an R in your calculator. It is a measure of the strength of the linear equation or the relationship. So no matter what you put into STAT, your calculator is going to give you a line of best fit. But if you turn on the correlation coefficient, it's going to tell you, hey, this is a really strong association or this is a really weak association. Because if I'm a business owner and it's a really weak association, it's basically telling me it's not super reliable. Make sense? But if it's super strong, then it is reliable. Okay? It says, how can you tell if the correlation coefficient is strong or weak? In your calculator, and I'm going to teach you how to turn it on. When R is near 1 or negative 1, the relationship is very strong. 1 being a positive strong, and negative 1 being a negative strong. So it's basically telling you if it's a positive strong relationship or negative strong relationship. If R is closer to 0, like 0.2, it is super weak. Okay? So if R is near 0, the linear relationship is very weak. And then there's some examples right here. If you get a perfect 1 as your R, it's telling you those dots are in a perfect line. There is nothing off. It is a beautiful linear relationship. It is the strongest you can get. This would be R being really close to 1. See how close the dots are to forming a straight line? So maybe like 0.8, 0.9. Okay? This would be a strong negative, and this would be close to 0 because there's really no relationship going on. Do y'all understand how to read it? Now, how do you turn the R on in your calculator? To turn it on in your calculator, write this down. You go to second catalog, which is second 0. And then you scroll down, and yes, you actually have to scroll down till you see diagnostics on. And then you're just going to turn them on by hitting enter. So let's try that together once you're ready. Okay, so see if you can find catalog. Did y'all find it? Right with a 0 in blue. Do y'all see it? So you're going to go to second 0 or second catalog. This whole thing is going to pop up. You're going to take that arrow and arrow down and just hold it down until you go to the D's, you're looking for diagnostics on. Right here. So it says diagnostic off first and then diagnostic on. Did everybody find it? Okay, you're going to make sure the arrow's pointing at it, hit enter, and then hit enter again until you see done. That means now your diagnostics are on, and it's going to tell you the R when you use stat. So our data's still in, so go to stat edit. Your data's still there, so leave it there. Okay? If you cleared it out, just watch with me. And then we're going to go to stat calc option 4. And this time it gives us an equation. Is that equation the exact same equation we just wrote right here? And it gives us an R. I have no idea what R squared is, so just ignore it. Okay, the R is the strength of the correlation. Is 0.98 very close to 1? That means this is a very strong relationship, and you can see it when we graph it that the dots are very close to making a straight line. Does that make sense? Okay, so now with knowing that and having our diagnostics on, let's go do 2 of these examples at the bottom. They want you to draw a line of best fit and write an equation for the line. We're going to write the equation first, and then we're going to draw a line of best fit, okay? What do we need to to make an equation? We need the coordinates, right? So we're going to make a little table over here. And we're going to have to do our best job to write these coordinates down. Every single coordinate, okay? So let's start at the bottom. What is the x value of this dot? And the y value is -4. This one would be like 0, -2.5. Y'all agree? Okay. This one, where do y'all think I'm at on the x-axis? 0.5. Where do you think I'm at on the y-axis? Maybe -1.5, 0.4, whatever. What do y'all want to do? 1.5. All right, this one's easy. It's 1. This one looks like 1.5. Am I going too fast? Y'all got it. And then 2.5. Okay, this next one is on the x-axis at 2. And on the y-axis, it's like at 4 and it's barely above it. So are y'all good with 4.1? Will our answers perfectly match on this? No. Should they be very close? Yes. All right, so let's go do this in stat. Edit, clear out your list. Okay, go to Stat Calc, option 4. Write the equation of the line of best fit. We're going to round to the 10th place. So what's my slope? 2.8, so y equals 2.8x. And what's my y-intercept? Minus 1.9. Easy? Now, I want you to identify the correlation coefficient. What is the R? Okay, write that down right below it. The R is 0.97. 978, so 98, yeah. And then tell me, is that a strong relationship or weak? Strong what? Positive or negative? If the R is positive, it's positive. And you can see it because it's going up. What do y'all think? Super, super easy, yes? Okay, let's skip the middle one and go to the last one. We're going to do one more. So I need to make a table. Let's start from left to right. So this left dot is at -3, 0. This one is at -1, -1. Oop, there's a negative right there. This one is at -2, -2. This one's at 0, -3, and it doesn't matter what order you go in, you just need the dots. This is at 1, -5, and this one's at 2, -6. When you write your equation, round to the 10th place. When you do the correlation coefficient, I would round to the hundredths place because it's just more accurate to see how strong it is. All right, is this a strong or a weak relationship? Strong what? Strong negative. All right, you're going to save this part because we're going to go over this part on Monday. Y'all hear me on that? We're going to go over that on Monday. I'm going to pass out your... All right, on 1 through 3, all it wants you to do is tell whether there is a positive correlation, negative, or none. Okay? On 4 through 5, it wants you to make a scatter plot. So you're going to go graph the points. Then it wants you to draw a line of fit. Take that off. I don't really care if you do that. Then it wants you to write an equation for the line. And then I want you to identify the correlation coefficient. Write that down. Identify the correlation coefficient. What does that mean? The R. So 3 questions. You're going to make a scatter plot. You're going to write an equation for the line of best fit by using stat, and then you're going to identify the R. So right here, you would graph it, and then you can put your equation, and then you can put your R. And that's what you're going to do on 1 through 7. Okay, flip to the back. 8 and 9. Wants you to do kind of the same thing. It wants you to make a scatter plot. Describe the relationship. So you're going to say positive or negative. Don't forget to say that because that's a question. If possible, fit a line to the data. Mark that off. We're not going to draw a line. But you are going to write an equation for the line and then identify the R. So over here you'll have 3 answers. You'll have an equation, an R, and then you'll have the correlation. So it should say positive or negative. Make sense? And then 10 and 11, you're going to have to answer each question about the data. You have to read each question. Please don't skip them. They're actually very easy. It's literally like graph the data. Is it positive or negative? Stuff like that. Okay?